Happy morning, my dear children. The last class we discussed about the 7th lesson chemical kinetics, some of the few problems, including some theoretical question. It's a very simple, easy question. Today also, that means up to 12 questions we finished, we completed. Today, we have to learn we have to discuss some question, that means collision theory, that's already over. Arrhenius equation, that is also already over. What are the examples of first order reaction, and about what is about the pseudo first order reaction. So a pseudo order reaction, okay? Anyhow, these questions are over. You learned that one, including some problems, having some problems. We need to do that problem, okay? I think that question number 15, 18, 19, 20, 21 and 22, these are some questions. If you have time, we can discuss all the questions, otherwise, at least we can be learned at least up to 20 questions. Okay? Very simple problem. And especially the question number 20 is a very important question. Try to do all the question. Please all of you take the note. We can write the question. Please all of you take the note. My dear children, today our learning objectives to learn about lesson number 7, chemical kinetics, book back question. Lesson number 7. That's the first volume plus 2. So, first volume, lesson number 7, chemical kinetics, question number 15, 18, 19, 20, 21 and 22 question. It's a book back question. The last class we discussed the remaining questions. That means from the 14 question, I think that 12 questions are over. The remaining 2, collision theory and Arrhenius equation also. The previous video I told you that. Today we have to discuss about the question number 15. What is about the question number 15? The decomposition of Cl2O7 at 500 Kelvin in gas phase to Cl2 and O2 is a first order reaction. After 1 minute at 500 Kelvin, the pressure of Cl2O7 falls from 0.08 to 0.04 atm. Okay. Calculate the rate constant in second inverse. Okay, that's the question. Okay. Clear the question? The decomposition of Cl2O7 at 500 Kelvin in gaseous phase to Cl2 and O2 is a first order reaction. After 1 minute at 500 Kelvin, the pressure of Cl2O7 falls from 0.08 to 0.04 atm. Calculate the rate constant in second inverse. Okay, that's a question. First to write the equation. Formulas. What are the formulas given? You should be writing the rate constant K. What is the rate constant? K is equal to, when we know that one, K is equal to, first of all, you should write the question number, okay? Sorry. Write the question number. The question number is 15. That is lesson 7, chemical kinetics. Chemical kinetics, book back question. Page number 230. Book back question number 15. I think that question number 15. First one. Okay, question number 15. Okay, now you should be writing the formula. K is equal to 2.303 divided by T log A naught by A. This is a equation. This is a formula. Okay. Here, what is the value about the A naught? A naught given A naught 0.08 A 0.04. Okay, that is a given. Okay, and about T, time T is equal to 1 minute. 1 minute. That we can write that is equal to 60 seconds. 60 seconds. So you can be substitute this one. Then K is equal to 2.303. 2.303 divided by 1 minute. You can write 1 minute. Log 0.08 divided by 0.04. 0.08 divided by 0.04. Okay. Then we can rewrite this log 2. 0.08 divided by 0.04 is equal to 2. Okay. So we can write K is equal to 2.303 log 2. Clear? So K is equal to 2.303 log 2 is equal to 0.3010. Log 2 is 0.3010. Okay, so multiply 0.3010. Okay, clear? So what's the answer? K is equal to 0.6932 minutes. Okay, minutes inverse. Okay. Then K is equal to 0.693. We have to divide by seconds. Okay. Minutes here by second. 60. That is a second inverse. Okay, then you have K is equal to 1.153 10 raised to minus 2 second inverse. This is the rate constant second inverse. Okay, please write fast. Okay, this is the question number 15th question. And now we have to discuss about question number 16. What is about the question number 16? Give two examples for zero order reaction. Give two examples for zero order reaction. That's a page number 250. Page number 215. Question number 16. Question number 60. Answer. Where is the answer means page number 215. Okay. So they are having examples of zero order reactions. At least this is the 2-mark question. At least you should be select any 2 is enough. Okay. Those who are willing to learn, we can be select 3 points. So example, page number 215. Any 2 example. Okay. Then question number 70. What's the question number 70? He explains pseudo first order reaction. Page number 240. 2014. That's a 3-mark question. This is the 3-mark question. Top of the page, I think that the first page is third line. First, top of the page, first paragraph, third line. The second order reaction can be altered to a first order reaction by taking one of the reactants large excess. Such reactions is called a pseudo first order reaction. And we consider the reaction acid hydrolysis of an ester, that equation up to the last. Thus it follows the first order kinetics, that much. Okay. Next, what's the next question? Question number 13 also. Okay, question number 13. Explain collision theory. Explain briefly the collision theory of a bimolecular reaction. Page number 270, 280, 290. Okay. Page number 270. Then 270. That's having the last that page, last paragraph, collision theory. And next page, 280, full. And about the next 290, after the last equation. Okay, the last equation. Next about 14th question. Question number 40. Write Arrhenius equation and explain the terms involved. That's a 2-mark question. Page number 220. Page number 220. The last having equation. K is equal to AE, the power minus EA by RT. And next side, that page 220. That page, the top of the page. Where A is the frequency factor, R is the gas constant, E is the activation energy of the reaction, and T is the absolute temperature in Kelvin. That much enough. That's one of the 2-mark question. Okay. Page number 220. Okay. Next one. Question number 80. Identify the order for the following reaction. What is about the rusting of iron? Next one is the radioactive disintegration of uranium 238. Question number 80. Question number 18, okay? Okay, question number 18. Identify the order of the following reaction. Then we have to say which order. Rusting of iron is in which order? That's the question. And about the radioactive disintegration of uranium 238. That is also which one? And third one. Third option also having 2A plus 3B gives product. That is which order? Okay, that is one of the 2-mark question. First one, rusting of iron. It is a zero order reaction. Zero order reaction. Second one, radioactive disintegration. Of uranium 92 238. Which reaction? That is about the first order reaction. third one. 2a plus 3b gives product. Here you should be write the k. What is about the k? Rate constant k. Rate k into a. Write the reactant 1 by 2, and also b 2. Next, you should write the answer order with respect to a is equal to 1 by 2. Okay, a is equal to 1 by 2. Order with respect b is equal to 2. What is the total order? Total order means 2 plus half. What is the total order? Two plus half is equal to 2 half. Okay, the total order is what? 2 half. What is the next question? A gas-phase reaction has energy of activation 2000 kilojoules mole inverse. If the frequency factor of the reaction is 1.6 into 10 raised to 13 second inverse, calculate the rate constant at 600 Kelvin. That's the question. Question number 90. Once again, question number 90. A gas-phase reaction has energy of activation 200 Kelvin moles inverse. If the frequency factor of the reaction is 1.6 into 10 to the power 13 second inverse, calculate the rate constant at 600 Kelvin. Once again, read the question number 90. A gas-phase reaction have energy of activation 200 kilojoules mole inverse. If the frequency factor of the reaction is 1.6 into 10 raised to 13 second inverse. So frequency given, am I right? Energy of activation, that is also 200 Kelvin mole inverse, that is also given. We should be calculate the rate constant at 600 Kelvin. So E value also given. Okay. So it goes to the formula Arrhenius equation. K is equal to AE, EA by RT. This is a formula. Okay. It's a formula. Here, what is the frequency factor? Frequency factor given. What's the given? Frequency factor A. A is equal to 1.6 into 10 raised to 13, 10 to the power 30 second inverse. That's the given. Okay. And also E, value of E. E is equal to question given 40.09, that is equal to 3.8 into 10 raised to minus 80. Okay, so this should be substitute this value. K is equal to, what's the value of A? 1.6 into 10 to the power 30 second inverse. Okay. into E. That is how much? 3.8 into 10 to the power minus 18. Okay. So, what's the answer? K is equal to, we are multiplying 1.6 into 10 to the 13 second inverse into 3.8 into 10 to the power minus 18. So, we get 6.21 into 10 raised to minus 5 second inverse. That's answer. So kindly please multiply this one. If you have a doubt, please call me, okay? Kindly multiply all of you. So the next one, we shall read the next question. Question number 20. Book back question number 20. Okay. For the reaction 2x plus y. For the reaction 2x plus y gives L. Find the rate law for the following data. Some of the data is given. That is, for the reaction x minute how much, y minutes how much, and rates. X minutes 0.2, y minutes is about 0.02 and the rate is 0.15, and about the x minutes 0.4, y 0.02, the rate is 0.30, x is 0.4 and y is about 0.08 and the rate is 1.20. So these are the given data. First you should be write the rate for that equation. What's the equation? 2x plus y gives L. This is the equation. So first to write the rate of this equation. This rate is equal to, we should write on k, one of the constant, x power n and y power n. So the rate is already given. What's about the rate? The data from the data, rate is equal to was 0.15. Rate is given. Okay. Then x value. What is about the x value? X is equal to 0.2 and y is equal to 0.02. So substitute here. Rate is equal, that is rate, the value rate is equal to 0.15 is equal to k into 0 x value 0.2 the power n, and about the y 0.02 the power m. Okay. And about write the equation. This is about the equation number 1. Which can be equation number 1. As per the data rate equal to 0.30 and about the x value is equal to 0.4, the y value is equal to 0.02 as per the rate. So rate 0.30 equal to k into 0.04 en 0.02 em. This is equation number 2. Clear? And also the data is given in the tabular column for rate 120 k into 0.4 en and y value 0.08 m value. This is the third equation. Anyhow, you should be divide equation 3 by 2. Equation 3 by 2. equation 3 by 2. So what is about the 3 by 2? 1.2. Okay, first one, write third equation. 1.2 divided by 0.3 equal to, first write k, 0.4 m, 0.08 m divided by third equation, k into 0.4 n, 0.02 m. Okay. So we are dividing, we get 4 is equal to 0.08 divided by 0.02. The total here m, okay, m because this is cancelled, that already know, k also cancelled. So this we can written as 4 is equal to 4 m. So what is about the m? M is equal to 1. M is equal to 1. Can you write? Next the same as per the date class. You should be write divide equation 2 by 1. Divide equation 2 by 1. Already I wrote the equation number 1. Equation 2 by 1. Okay. Okay. Anyhow, right? What's about the equation 2? Two by 1. What's about the equation 2? 0.30 divided by equation 1. You shall write equation 1 0.15 equal to equation number 2 k 0.4 n 0.02 m divided by equation number 1, that is k into 0.2 n 0.02 m. So the possibility, which are the possibility for cancelling? These are the possibility for cancelling. Okay. And about the k also cancelling. So can we see what is the answer? This will get 30 by 0.30 divided by 0.15. That is equal to approximately equal to 2. Am I right? 2 equal to 0.4 divided by 0.2 for n. Okay? Am I right? Then 2 is equal, this also can be written as 2 to the whole n. So what is about the n value? N is equal to 1. Here what is the value of m? M is equal to 1. N is equal to 1. Here. That is equation 3 by 2. Value of m is equal to 1. Equation 2 by 1. The value of n is equal to 1. Clear? So we shall write the rate. What is about the rate? Rate is equal to, as per the equation, that is, what is the equation? You wrote the equation. First to write the equation, 2x plus y gives n. Okay. So we can write the rate. Rate is equal to k into x1 y1. Okay. So .15 equal to k into 0.08 2, write 1 and 0.021. Clear? So we can written as 0.15 divided by 0.21, 0.021. Okay, that is, it can be written as K. We are taking. Okay, that is, it can be taken as what? K. So as per dividing, what is about the K is equal to 37.5 mole inverse, and also as per the unit LS minus 1. This is the answer for the K answer. Okay, the rate. Next question number 21. What is about the question number 21? How do concentration of the reactant influence the rate of the reaction? Concentration of the reactant influence the rate of the reaction. That's a question. To write the answer, consider a first order reaction. A gives product. You should be write the rate. Rate is equal to K into E. If the concentration is double, if the concentration is double, that is R1 is equal to K into A. So what is about R2? R2 is equal to K into 2A. Double means 2A. Okay. So therefore we can be write R2 by R1. Okay. R2 by R1. What is about R2? K 2A R1. That is KA. Okay. So what's the answer? We are cancelling. What's the answer? Is equal to 2. Okay, 2. That means R2 is equal to R1. R2 is equal to 2R1. What's the meaning? That means, this means that the rate of the reaction is doubled. Alright? So, when the concentration of the reactant is also doubled. Clear? What is about this means? The rate of the reaction is doubled when the concentration of the reactant is also doubled. Let us discuss about this is about the first order reaction. We can discuss about the second order reaction. Consider a second order reaction. That is, rate is equal to K into A 2. 2 means what? Second order reaction. Okay. That R1 is equal to K into A power 2. If the concentration of the reactant is doubled, that's the question. If the concentration of the reactant is doubled, R2 is equal to K 2A2. Okay, that is equal to K into, that is 4A2. So we write R1 by R2. Okay, R1 by R2. This is about the R1, this is about the R2. So we should be right what? R2 by R1. Okay, R2 by what? R2 by R1. What is about R2? K, am I right? K into 4A2. So write 4KA2 divided by R1. What's up with R1? K. A2. So what's the answer? We get 4. What's the answer? 4. That is R2 by R1 is equal to 4. R2 by R1 is equal to what? 4. So what is about the R2? R2 is equal to cross multiplication. R2 is equal to 4 R1. This is the answer. So what is about that? If the concentration of the reactant is doubled for a second order reaction, rate is increased by 4 times. Clear? What's about that? If the concentration of the reactant is doubled, concentration double means for the second order reaction, rate is increased by 4 times. Okay, it can be shown that the third order reaction, if the concentration of the reactant is doubled, the rate is increased by 8 times. Okay, that's the meaning. If the concentration of the reactant is doubled for a second order reaction, the rate is increased by 4 times. Okay, suppose if the concentration of the reactant is doubled for the third order reaction, the rate is increased by 8 times. How much times? 8 times. Okay. Okay. Anyhow, we have one more question. It can be discussed later. Okay. Anyhow, I am giving the assignment today. Assignment, the important question. Please all of you write the assignment. Assignment. Book back question. Question number 20. Okay, this is the assignment. Okay, assignment question number 20. Please all of you write the assignment. Thank you all of you. Thank you. Have a nice day.